When 415 college students in USA were surveyed, under 50 said they have a passport. Construct a 95% confidence interval for the proportion of college students that have a passport. Round to the nearest thousand. So first try to extract the information. So we have 450 college students. So this is sample size. So n is equal to 400. And out of that 110, so they said that they have a passport. This is x value. X is 150. And from here point estimate p hat. So that would be 150 out of 450. So that's approximately equal to 0.3614. Approximately. So we have to find a 95% confidence interval. That we have to find. So first we have to find this confidence interval. There should be two assumptions that should be satisfied. The first is that the sample size should be less or equal to 5% or 0.05 times n. And the second condition is that this n times p hat times 1 minus hat, this should be greater or equal to 10. So now we are talking about all college students in USA. So they are in millions. So definitely 415, the sample size n, right here. So this is definitely less than 5%. So we say that okay, the first condition is true. For the second condition, so we can quickly compute it. So n is 415. So we would say 415 times p hat. So that is 0.36145 times 1 minus 0.36145, which is approximately equal to 95.78, and which is definitely greater than 10. So this second condition is, so it means that our model would work, and we can find this 95% confidence interval. And confidence interval would be equal to that p hat plus minus e. And e is margin of error, right? So p hat is a point estimate, e is margin of error, and margin of error is defined as z sub alpha by 2, and then the square root of p hat 1 minus p hat divided by n. So now we have to compute that z sub alpha by 2, this value, and then p hat, we already have this value here, and n we already know that. We just plug in there, find e, and then okay, find the p hat plus minus e, right? So this one. So first find this z sub alpha by 2. So we know that the confidence interval is 95%, right? So it means that the alpha would be 5%. So alpha is 5%, and alpha by 2, that would go to 0.5%, which is equal to 0.05. So then z sub alpha by 2. So if we draw this normal curve here, so z sub alpha by 2 would be a value here in standard normal distribution curve, for which the area on the side here, this area, this should be equal to alpha by 2, and alpha by 2 is this one, 0.025. So this should be this area here. So if this area on this side is like say 0.025 or 2.5%, then the area on the other side would be 97.5%, the remaining, or 1 minus 0.025. So 1 minus 0.025, so which is equal to 0.975. So now what we have to do is that from the standard normal distribution table, so we will see that this value here, right? So this one 0.975. Look for this area and then find the corresponding z sub alpha by 2 value, and that would be this number, 0.975. So this is this value here, right? So this is the area, and this is corresponding to z value. This is 1.9, and the second digit would be like say 0, 1, 2, 3, 4, 5, and 6, right? So this is the z sub alpha by 2 value would be 1.9 and 6, second digit 6, right? So now just use this z sub alpha by 2 value, so 1.9 and then 6 column, so 1.96. So that's a z sub alpha by 2 value. You can also compute it using your calculator with inverse norm. This would also give you this z sub alpha by 2 value. So anyway, so once we have this value, and now we have to just plug in here, this one here, then p hat value we already computed, plug in here, and then n value, and this would give us e. And remember our p hat value was this one 0.36145, right? So this one here. So now just like say plugging in these values here in this equation, and this would give us e. So e would be equal to z sub alpha by 2, so that is 1.96, and then square root of p hat, so that is 0.36 145 times 1 minus 0.36145 and divided by n is 415. So this would simplify equal to approximately equal to 0.04 this is e value. So our confidence interval would be p hat plus minus, right? So p hat plus minus e, right? That was our confidence interval, and p hat was 0.36145 plus minus 0.04622, and this would be equal to, so once you subtract, once you add, so once you subtract, you would get 0.3152, and once you add, so you would get 0.4077. Right, so this is once you add these values and you subtract these values, and our actual question says that you have to round it to the nearest thousandth. That's your final answer. So then this confidence interval, the nearest thousandths would be this point here, right? So this third digit. So you round it here. So then our answer would be 95% confidence interval would be 0.315, and the upper limit would be 0.408. So that's your answer.